Watch this. I'm just going to tell my agent what I want. Get me Qwen 3 4 billion parameter model, the MLX version in 3-bit. There it is. Q1 34 billion. I'm not even giving it the exact model name. The transcription even messed it up. Let's go. Got it. Already on your shelf. No download needed. You just found the right one, grabbed it, and loaded it up. Gave me the location if I want to use it in another tool, or gave me the exact command I need to run that. And check out where it found the file. It found it on this external ACASIS drive under MLX Community Qwen 3 4B 3-bit. Notice that's not the Hugging Face cache with gibberish folder names and blobs and weird file names and references and snapshots. I can't stand that. Instead, it's exactly in the right place where it should be, named the way I want it. And this is how I get my LLMs and my image and video models now. And I think by the end of this video, you're gonna like this method so much that you're gonna end up using this too. Now, here's the thing. This right here is the brand new M5 Max. I'm not bragging or flexing or anything. I just need it, okay? And I did get this one with 8 terabytes of storage. And I only have 1.8 terabytes left on this thing. The reason I'm running out of space is, can you guess? Yeah? Models. Local LLMs, image generation weights, video generation weights, multi-quant variants of the same model because I want to be able to compare. I need it for this channel. Hundreds of gigabytes just evaporate. And the worst part is half of these are the same files I already have on another machine somewhere else, or even on the same machine in multiple different locations. I just couldn't find them, so I re-downloaded them. So, being that I'm a software developer, I built a tool for this. Not by hand, come on. It's open source, it's called Model Shelf. And it ships with an agent that teaches Claude Code, or really any agent that can run a shell command, to use it automatically. I'm gonna walk you through that, but first, the hardware that makes this whole workflow actually viable. Now, you might have seen a bunch of my videos on these little mini ACASIS things, and so did ACASIS. So they were kind enough to sponsor this video and ship me the new ACASIS TB504. This is their new Thunderbolt 5, 80 gigabit per second, 4-bay M.2 NVMe drive, external enclosure. It is a hefty boy. There's a lot more detail on the Kickstarter page of this. By the way, the Kickstarter is just how some brands launch their new products now. Even established brands do it. Pricing, launch updates, all of that will be in the description down below. But here's how I describe this thing. It's not just another SSD enclosure. Let's plug this in. And I want you to listen to the sound right now. This thing sits just between the portable powered SSD that we have here and a full NAS rig that most of us don't actually want to deal with. Now I've turned it on and I can't hear a single thing. That's because this thing is actually completely fanless. I'm gonna bring this up to the mic so you can hear this. Yeah, there's zero sound coming here. It's kind of like using the MacBook Air in that you can be absolutely quiet because there's no fans. And this is very different than that DAS I showed in a video last year where I had to move it away from my desk in order to even be able to use it because it was so loud. The other unique thing about this one is that it gives each bay its own 80 gigabit lane, not split 4 ways, each one. But how is this relevant to what we're talking about today? Here's the thing about local LLMs. Qwen 3 14 billion parameter model at in-for quantization is 8 gigabytes. A 70 billion parameter class quantization is 40 plus gigabytes. Image and video weights can get up to hundreds. And if you're doing RAG data sets, vector databases, it's gonna be gigs upon gigs. So yeah, this is an external enclosure that can do all kinds of things like 8K video, big photo libraries, but that's not why we're here today. And as soon as I plug this thing in, there are my 4 drives that I've loaded up in there available to use right away. Here's just one of the drives. Yeah, we're getting up there. 6500 write, 6000 read, around there. And that's Blackmagic disk speed, which is generally a little bit slower than Amorphous. So here is Amorphous, 6900 read and 6600 write. And they're running at the same time on 2 different disks. So this thing is fast and quiet, and it's got 2 80 gigabit down ports. So you can use them to plug in monitors, for example, which is not something you usually see in enclosures like this. Now, a fast drive doesn't alone solve the actual problem. Where do we put our models? How does the agent find them? How do you download models and how do you keep track of them? Well, before Model Shelf, I used to just create a models folder and hope to remember, but I knew there had to be a better way, and that's what this is. This is the GitHub repo, and you can install it for yourself with just one command. It's right here in the documentation, actually. Model shelf at alexiskin1/model shelf. This will do two things. One is it'll get that tool, model shelf, but it'll also add the skill that I mentioned before. So the second you install it, Cloud Code already knows how to use it. You don't have to teach the agent anything. But if you don't have Cloud Code, if you just rather use model shelf, you can still use it with your favorite Python environment. Once it's installed, you can run model shelf init, and boom, this will tell me what has model shelf already installed on it. For example, it's already installed locally on this machine, but we have a few new drives right here where it's not yet. So let's pick one of those. And if I go to that drive, there it is. Model shelf, it's got models, it's got the directory structure, your Llama CPP models, your MLX models, and your other models, safe tensors. If you're not using a Mac, for example, you want to use VLLM or Llama CPP on another machine, but that uses safe tensors file type. There's no path to copy and paste, you're done. Now, here's the part that makes the agent and the skill really useful. You might have asked an agent previously for a model, right? And it says something like, oh, that model doesn't exist because its training data is maybe 6 months old. Yeah. Well, with model shelf, the agent doesn't argue. It actually checks the live hub. The hub is the source of truth, not the model's memory. Get me Qwen 3.5, the 9 billion parameter model in 4-bit quantization for Llama CPP. By the way, I'm using Super Whisper, not sponsored or anything, but I kind of like it. Holding down the button and speaking to it, it's just so easy. However, it doesn't always get things right, like QEN instead of QWEN, and Llama CPP is spelled wrong. But anyway, let's see if it gets it. So there it goes. It loaded the skill. The input is loose, so I'll search the Hive first. Found it, and found it exactly what it needs, what format it needs. It's gonna grab Unsloth's version of it because it's the cleanest GGUF repo with the most downloads. And now it's grabbing it because I don't have it anywhere local. But if you try this with Cloud Code without model shelf, it'll tell you confidently that that model does not exist, unless you of course ask it to check the hub first. But model shelf takes care of that for you. Done. Look at that. It gave me the full path. So now all I gotta do is just plug that into my Llama CPP. It even gave me the CLI command if I want to run Llama CPP, and Llama server commands too, pointing to the exact place where that model lives now, which is going to be on this ACASIS drive 1 under GGUF Unsloth. There it is, Qwen 3.5 9B. There's the GGUF file. Now, you can use model shelf with any drives, internal, external, or a combination. But here's where the 4-bay architecture of this ACASIS actually pays off. Each bay shows up as its own volume on the Mac in this case, not one big stripe. You could, we'll get to that in a moment, but now it's 4 independent drives, each one with its own 80 gigabit lane to the controller, and you don't have to fill all 4 on day one. Start with 1 or 2 drives and add more as your model library grows, or use some drives for some things, for like MLX, use another drive for GGUF, run it with Llama CLI, and give me a test prompt. And there it goes. In one paragraph, explain what 4-bit quantization does to a large language model and what the main trade-off is. So yeah, it started thinking, but let's increase the token limit so we actually get an answer. And while that's happening, I want to keep an eye on this. Yeah, so there it goes. It went from 68 gigabyte usage on the system to about 76, which makes perfect sense. And if we check the GPU history, there's that little blue spike that represents the GPU being used. So because this is Thunderbolt 5, your model loads instantly into memory from the ACASIS drive, the external drive, used by the LLM runtime directly from memory. So now it's loaded in, and that is a really fast transfer. Here's our final answer. 4-bit quantization compresses a large language model, blah, blah, blah. Now the internal drive is still faster on this machine because this is an insane M5 Max with 8 terabytes. So I'm getting like 15,000 megabytes per second, which is insane. So it's gonna be a little bit faster. For example, a 70 billion parameter model is gonna be a few seconds later time to first token than if the 70 billion weights lived on my internal SSD. But that's the trade-off. Okay, so each bay is fast, but here's where it gets interesting. I put model shelf on 3 of these drives, and I put a couple of different models on each one. List the models that are available. Model Shelf is going to look through everything that's available that has Model Shelf initialized and give me the listing of all the local models that are available. There it is. Qwen 3.59 billion for Llama CPP, Gemma 34B for Llama CPP on another drive, Qwen 34B 3-bit MLX on a third drive, and on the local shelf I had Bartowski's small LM2 installed. So even though I have my models in multiple different places, as long as Model Shelf knows about it, it can find them all and let your agent know about it. So the agent doesn't care about which bay a model lives on. It just asks Model Shelf, gets a path, and uses it. And any one of them could move to another Mac and still works. Now here's the stuff I actually care about. First, the paths are clean. It's GGUF, then Unsloth or Bartowski or whoever makes the models, the publisher, then Qwen, the name of the model, I should say the repo name, and finally we get the file. That's literally the model's address on Hugging Face. Do I need to remind you what Hugging Face's own cache looks like for models? Look at this. Models, dash dash, Qwen, dash dash. What is this? And then you have blobs. What are these files? Those are your model weights, but how do you even make sense of them? If I need to point Llama CPP or MLX at one of these, where do I point it at? This always bothered me. There's also refs, main, there's snapshots, that's where the configs are. It's just a mess. Oh, and the best part is there's no server running in the background, no MCP, no daemon, nothing sitting in my menu bar. It's just a shell command that spits out JSON. Oh, and one more thing. If I unplug this, if it's not plugged in, the agent doesn't just quietly dump 8 gigs onto my internal SSD anywhere and act like everything's fine. It'll stop, tell me the drive is not mounted, or give me the option to use the internal. It just won't do it without my permission. Now, here's one more fun trick we can do with this enclosure. And if you remember my video from last year where I had 3 of these external drives all plugged into my Mac at the exact same time with 3 cables, I was able to RAID 0 them. So have them all treated as one big drive in RAID 0 configuration, made them all essentially faster and have more space together. For AI storage, RAID 0 is the right call. And there's a few reasons for that. One, models are regeneratable. Every weight on your shelf can be downloaded from the hub. There's no original you can lose. So redundancy, which other RAID options give you, like RAID 1, RAID 5, RAID 6, RAID 0 doesn't give you redundancy, it gives you speed. So if you lose one drive, it's all gone. But redundancy isn't the problem in this case with models. 2, inference is bandwidth bound. So loading a 70 billion parameter model into VRAM means moving 40 gigs through storage controller as fast as possible. We saw that the internal drive gets up to 15,000 megabytes per second. RAID 0 with 4 drives should give you theoretically more than that. I'm about to try that. And 3, I already mentioned, if a stripe fails, you just re-download the model. For video projects or photos, don't do that. You want to use RAID 5 or 6 for that. Those files are irreplaceable. So models, that's fine. Here I am in Disk Utility on a Mac. I go to RAID Assistant. I pick striped RAID 0 and then select all my drives. TB504. Let's go with APFS and chunk size of 256 and create the RAID array. Now this will erase all my models that are on there already, but I'm curious about the speed here. RAID created successfully, and there it is right there, TB504. Let's check out our disk speed. Well, it's about the same, but I guess it was worth the test anyway. Now you know. I can just initialize Model Shelf on it. Get me Gemma 3 4 billion parameter model in MLX format at 4-bit quantization. There it is. It's grabbing it, building the structure, getting all the files from the hub, and I mean Hugging Face hub. You don't leave that comment. So now, if I want to use the model, it's there and available, and all I got to do is just tell my agent, go ahead. You were supposed to record all that. So there we go. There we go. Resolve still works and the agent doesn't care. So remember where we started? 8 terabytes out of space, drowning in models. Well, not anymore. They're gonna live on the TB504 now. My internal drive will have space. The agent will find all the models wherever they sit. Model Shelf is open source. You can check it out. The ACASIS TB504 is on Kickstarter. Both links are down below. There's an early bird special while it lasts. Let me know in the comments how you store models right now and if you think you're gonna use Model Shelf. If you like this video, you're gonna like this one over here. Thanks for watching, and I'll see you next time.